Alrighty, so today we're doing 4-6 quadratic functions, scale changes, and reflections. So you've already learned or relearned or reminded yourself or whatever how to do the h and the k. That's just where the graph just slides to the right and up, slides to the left and up, slides to the left and down, or slides to the right and down. It just slides around. Now we're going to stretch this graph up like it's a rubber band stretching. When it stretches, okay, it's going to get narrower. It's going to come in because you're pulling it up, so it only makes sense it's going to get narrower. If we are compressing it, that we're going to be flattening it out, like there's pressure pushing down on it, and it's going to get flatter, so it's going to get wider out here when it's compressed. Okay, so let's go back over the parent function really quick. The parent function of a parabola is y equals x squared. The vertex is here at 0, 0. The axis of symmetry is the x of your vertex. There's an imaginary line running down like this at x equals 0. The domain is all real numbers, and you can write it different ways. All real numbers symbol, or from negative infinity to positive infinity. The range is y is greater than or equal to 0. This graph, how tall is this graph? It is everything from 0 up. Okay? Another way to write that would be to say it's equal to 0, but then it goes up, up, up to infinity. Okay? Okay, so we are going to work on our stretches and compressions. They are giving us notes here to remind us what the k does. If it's a positive k, it goes up. If it's a minus k, it goes down. If it's a negative h, it's going to the right. If it's a positive h, it's going to the left. Okay? Then we're adding stretch and compress, which was what I was talking about a minute ago. This is a typo, shouldn't be there. Okay, if the a value in the front of the equation is greater than 1, so normally you would have a number, not a letter a, but a number. If it's greater than 1, it's a stretch. So it's going to get kind of pulled narrower. Somebody is up there like a rubber band stretching it. Okay? If the a value is like a fraction, so here would be an example, okay? Then it's a compress. If it's in between 0 and 1, which would be fractions. You're not going to really see decimals in our class. I mean, maybe in another class. Here would be an example of a stretch. Okay, then if the negative is out in front, it reflects over the x-axis. So here's your x-axis. That would mean instead of up here, like the parent function is, you see the parent function back up here is facing upward, it's pointing upward. If there's a negative, it just reflects, it just flips over the x-axis and faces downward, okay? If there's a negative on the inside, it reflects over the y-axis, and we don't really do that much, so you can almost kind of ignore that part. We used to do that one, but we've kind of gotten away from that. Okay, so let's look at this guy. Get it copied down, and let's see what's happening with this. It says function notation, so we're going to put 2 out in the front, and then f x minus 1 squared plus 3. I should probably be using a darker color. Okay, so the vertex, we practiced that the other day. This is your h. This is your k. The vertex, the h is going to lie, but the k is going to tell the truth. The axis of symmetry is the x of the vertex. Okay, so it's 1. Let's talk about what this graph is doing. Looking at the h, how is it moving? Is it moving to the right or to the left? You would think a negative would mean move to the left, but that really means to move to the right. The plus 3 tells the truth, so going up 3. Now, here's your a value. I guess we probably should write this somewhere. A x minus h squared plus k. That's a very important thing for you to write down, a very important equation. That's the format for a parabola or a quadratic in vertex form. Okay, we're going to talk about vertex form later, but it makes sense this is called vertex form because you can pick out the vertex from it really super duper easy. Okay, back to this 2. Is it a stretch or compress? 2 is bigger than 1. Okay, so if you go back over here, 2 is bigger than 1. A is greater than 1, so that's going to be a stretch. Okay, so we're going to say stretch by 2. Okay, so what I would do is I would move it first. I would move that little guy. He's normally right here, right at 0, 0. We're going to go to the right 1, and we're going to go up 3. Okay, this is where the new equation is. Don't write this in right now, but let's review here. From this vertex, so this guy is gone. He's not important anymore. Okay, that was the old vertex of the parent function. Here's the new vertex, the bottom of the U. Remember, you go out 1 and up 1, go out 1 and up 1. And then from the vertex, you go out 2, and 2 squared is 4. So up 4. This is the squared function, so you're squaring all of your x's. Out 2 and up 4. Well, what I just drew in green is the parent function before it's stretched. We've got to stretch this guy. Okay? So instead of going out 1 and up 1, this right here, we're going to double it. Okay? So we're going to go out 1, and instead of going up 1, go up 2, because you're doubling it. It says to stretch everything by 2. So we're going to go out 2, and instead of up 4, we're going to go up 8, and it kind of ran off the grid. Okay? Our A value is, I was going to tell you something about the A value, and I forgot. So then you're going to do the same on the other side. It's going to be symmetrical, so if you're good at visualizing things, you know where to mark it. Okay, out 1, up 2, then from the vertex, out 2, up 8. And I just estimated the 8 there. That's probably 1, 2, 3, 4, 5, 6. Oh, no, that's good enough. I did okay. Okay. Make it a U, not a V, okay? So that's our new guy. You can sort of see how he came in a little bit. He's being kind of narrowed. He's narrower. He's coming inward from those green dots. The domain is still all real numbers. Even though it's narrower, it's still getting wider and wider and wider as you go to the right and as you go to the left. The range, though, where does the graph start? Remember, range is from bottom to top. Here's the bottom of the graph. It starts at 3, and then it goes up, up, up to infinity. It's equal to the 3, even though I didn't draw my graph great. It's touching the 3 line. Y is greater than or equal to 3. I'm writing it in both forms, interval and inequality, just in case, because you don't know how they're going to ask the question. Okay? So basically, the A value, let me see if I can find room. The A value is the rise over the run squared. If I did that correctly. I don't think I did that correctly. So ignore that. Hang on. Ignore that. I got to double check on that. Okay. Okay. Questions about that one? In your Delta Math, I don't think you're going to have one that has all 3. You're probably just going to have questions that have the 2 or the A value in the front. Okay. So let's look at this one. Now this is written in function notation. Let's write it in vertex form. So y equals, I don't know why I keep getting this pink. Okay, y equals 1/2 x plus 4 minus 2. Okay, what is the vertex? There's your H, there's your K. Remember, it's the opposite of your H. -4, -2, but not the opposite of your K. K tells the truth. H is a liar. Okay, the axis of symmetry is the X of your vertex. So X equals -4. Okay, what are our transformations here? Well, it's going to go to the left 4 and down 2. It's a +4. That tells us right and left. You would think plus would mean positive. It does the opposite. H is a liar, so it really means go to the left. And down 2, that's easy. So is this a stretch or a compressed? Does this get compressed, like squished, or does it get stretched? Since it's less than 1, it's in between 0 and 1, it gets compressed. Okay, I'm going to pause this for just a second. Okay, so sorry about that little commercial break. You probably didn't even notice it. Okay, so now we got to graph this thing. Okay, so I'm going to graph the vertex first. Okay, -4, -2. Okay, or, well, you got a couple options. You can just look at your vertex. If you got your vertex written correctly, that will work. -4, -2, or I could have said, hey, my original vertex was here, and so I need to go to the left 4. You can be looking up here and down 2. So you got a couple of options there, how to get that vertex graphed. So you know it's going to make a U shape like this. So you got to get that in your head. You just got to get the other points correct. Okay, so this one would normally go up 1, out 1 and up 1. You would normally have points here and here. But instead of going over 1 and up 1, you half it. So it's here, okay? So it's going to be half of that distance, okay? And then you do that on the other side. Okay, then go back to your vertex. Normally you would go out 2, up 4, 1, 2, 3, 4. Okay, but half that distance, instead of going up 4, you're going to go 2, because the A is a half. It's compressed by a half. Okay. Okay, so what I was trying to explain earlier was this. Okay, I was right. It's the rise over the run squared. So if our A is, and it doesn't work good with the fractions to do it though. So that's kind of why I think I was hesitant to do it. But you might want to write this down just to have it. I think we could do it better with this one. The rise over the run squared. We'd have to square 2 and get 4. I guess I'll play with that later, maybe come back and do a separate video and help you out with that. Okay, so we got this compression. So basically, on Delta Math, you're going to grab the point and just half it. Like if it's here, you're just going to half it. If it's here, you're going to here's your baseline, you're going to half it. And I might be able to do a video or just show you in class. And hopefully you can join me in Zoom. Okay, so I'm going to draw it in. That was a pretty good one. I have to do that one pretty good. Okay, the domain is all real numbers. You might see it written like this, from -infinity to +infinity. Now our domain, I said it backward, didn't I? Our domain is all real numbers from -infinity to +infinity. Our range is from 2. Remember, you start at the bottom and you go up. Okay. Are equal to 2. Okay. Okay, so now let's do reflections. So I see a negative in the front. We're going to rewrite this. We're going to say y equals negative 3 x plus 1 squared minus 2. What is the vertex? It's going to be the opposite of the h and then the k just like it is. Okay, the axis of symmetry is x equals negative 1. I guess I should have been drawing in the axis of symmetry on those other ones. Okay, this time, let's do the h and the k first. It's going to go down, nope, not down. Well, it will, but let's do the right left. It's going to go to the left 1. It's going to go down 1. Left 1, down 1. Okay, left 1, down 1. Now let's talk about this negative 3. The negative part is going to make it reflect over the x-axis, and it's going to make it stretch. It's bigger. 3 is bigger than 1, so it's a stretch by 3. Okay, here's where the parent function normally is. The parent function means nothing's been done to it yet. It's plain. Okay, let's graph that new vertex. Okay, we're going to graph the new vertex. Down 1, over to the left 1, down 1. Okay, now you got to you might even just lightly pencil in, hey, it's going to reflect. It's going to go down. Okay, so then we have to stretch it by 3. So instead of going, let me find a good color, red. Okay, instead of going, okay, it's going to go out 1. Normally it would go out 1, up 1, out 1, up 1. But it's going to go down 1. It's going to go out 1, down 1, out 1, down 1. But instead of 1, everything gets multiplied by 3. So out 1, down 3 from this point, not from the 0, 0, okay, from the vertex. Out 1, down 3. Now we're going to go out 2. Normally you would go down 4. Remember, it's from the vertex, it's out 1, up 1, and then out 2, up 4. Okay, so out 2, 4. 4 times 3 is 12, so it's going to be like way down here, way further than I can even go. And that's okay that you can't graph it. Okay? So it got stretched. See how it's narrower? Well, I didn't quite draw in the perfect parabola there. Domain is all real numbers, but this time our range might be a little bit different. Bottom to top. What's on the bottom? Negative infinity is on the bottom. And where does it stop? It stops at negative 1, and it's equal to negative 1, so we use a bracket. If it were in inequality notation, we would say our whole graph is less than negative 1. Here's negative 1. It's all lower than negative 1, or equal to negative 1. It is touching, even though I didn't draw it so great. Okay, let's see if we can write the equation of these graphs. Here's the vertex right here. Okay, so let's name that vertex. Here's 0. Nope, that's not 0, 0. Almost messed up. There's 0, 0. So what did it do? It moved to the left 1, 2, 3, 4. Okay, so it moved to the left 4, and it moved down 2. So let's get our h and our k done correctly. Okay, y equals x. You would think it would be minus 4, so it's going to be plus 4, and then down 2. Okay, let's see if it's stretching or compressing. Normally, from the vertex, it goes out 1, up 1, and it looks like it went out 1, up a half. So I think our A is a half. Okay, and it's facing upward, so it's not reflecting. It's a positive there, not a negative. But this one is reflecting. We know we're going to have a negative in the front. I'm going to do it down here. Okay, so y equals, where's my vertex? The vertex is at 1, 3. That's the h and the k. But when I put it in the equation, the h is going to be a liar. When you go to the right, it's negative. And then plus 3. And this guy has a negative because it's facing down. And let's see if we can figure out the A. Okay, let me use a different color. So when I go out 1. Normally I would go out 1, down 1 or up 1, okay? But instead I'm going out 1, down 2. So that means it's a 2. You can usually just tell by the first point, okay? And I know that's a little confusing, but it may take some practice. You'll have a few questions in Delta Math with that. Okay.